This is the first lesson for Algebra 2 Advanced, and this video is going to tell you the things I want to make sure you know from Chapter 1.1. Chapter 1.1 is review from back in Algebra 1, and there are 4 things I want to make sure that you've learned. Subsets of real numbers, putting numbers in order, properties of addition and multiplication, and unit analysis. I'll go through each of these 4. The first is the term, and first, by the way, let me make sure that I highlight this up here. I'm going to keep changing this number as we go along. The first is the terms and meanings for these subsets of real numbers. Now, all you really have to remember is this. Whole numbers start with 0 and climb upward. Integers add in the negative numbers. So there are no fractions here, nor are there any fractions here. Fractions come up with rational numbers. And rational numbers, think ratio when you think of rational. It's literally the ratio of 2 integers. Well, we just learned what integers are. So 3/4 is an example, but so is -4/1. If you write this as a decimal, then a rational number is going to end, or else it's going to repeat. Here's an example of a rational number that ends. 3/4 stops at 0.75. There's really nothing else to write. Whereas 1/3 keeps going as 0.333 as long as you want to keep writing 3's. Irrational numbers is the category that none of these things match up with. So in other words, they cannot be written as ratios of 2 integers. So for example, the classic example is pi, 3.14159. It keeps going from there, though, indefinitely. It doesn't terminate, and it does not repeat. If you ever plug in the square root of 2 in your calculator and try to find out what that number is, you're going to find similarly that it keeps repeating, it keeps continuing indefinitely. It doesn't repeat. Okay. Be sure that you notice that the first 3 categories here aren't separate from each other, but in fact they fit in like nested boxes, like Russian dolls. The whole numbers fit in with inside integers, and the integers fit in inside rational numbers. The separation happens between rational numbers and irrational numbers. Let's look at some examples. When you try to categorize a number like any of these, make sure you put it in the smallest category, the most specific category that you can. So for example, 293, well, that's a whole number. -47 is not a whole number, though, because the whole numbers start at 0 and climb upwards, so -47 belongs here in the integers. 5/9, well, that's a ratio, but it's not an integer, it's not a whole number. 0.184, same story here. This is not a whole number, not an integer, but it does stop. So let's put that in here as well with the rational numbers. Let's put it there. Now, 6/3 can be simplified down to be made 2. 6/3 really belongs here. And the square root of 3, like the square root of 2 that we just talked about, if you put it into your calculator, you're going to find that it's an unending decimal. I'm going to whip through the rest of these. You can pause at any point either to see if an answer that I've given here doesn't make sense, or to predict where I am going to put something, or maybe you'll come to class tomorrow and challenge me, suggesting that maybe I made a mistake. This is pi, by the way, if it's hard to read. This one, -√9. Well, the square root of 9 we know is 3, so that's really -3. Square root of 4 is 2. -50/5 is the same thing as -10, so that belongs here in integers. I'm going to assume that this never repeats because I don't see any repeating happening. And this I'm trying to put in I don't have much room to put it, but this is a rational number. Okay, let's move on. The second thing that I want you to know is how to put numbers in order. Sometimes the easiest way to put a batch of numbers such as these in order is to give them all the same denominator. Here, let's just do this a step at a time instead. So 7 halves, if you give them all the common denominator 12, 7 halves becomes 42 over 12. Likewise, if you change negative 7 fourths into 12ths, it becomes negative 21 over 12. Once they are all of the same denominator, then particularly if you use a number line, it becomes pretty easy to put these in order. But I want to make sure, in your homework tonight, for example, that you don't stop there. You convert these back. So what I actually end up seeing is not negative 32 over 12, but I end up seeing negative 8 over 3, and I end up learning that it belongs furthest to the left. And similarly, 42 over 12 is not where you end, but 7 halves belongs furthest to the right. Sometimes instead of converting to a common denominator, it's easier to convert all to decimals. Like in this case, it's easy to turn 8 to 8.0. If you can see that 15 halves is 7.5, then these first three are all easily converted to decimals. This is not going to be easy to work with either way, either as a fraction or as a decimal. You have to, and the MCAS makes great use of this insight, you have to be able to see that there are square roots near the square root of 10 that you do know. You do know the square root of 9, and you know the square root of 16. Now these happen to be negatives. The negative square root of 9 would be negative 3. The negative square root of 16 would be negative 4. So this is somewhere between negative 3 and negative 4, probably closer to square root of negative 3, since 10 is much closer to this side. So I'm just going to write it down as negative 3.1. Could be negative 3.2, could be negative 3.4 for all I know. It doesn't really matter. The point is, it's easy now to place these. 8 goes all the way to the right. 7.5 goes very close to it. Negative 2.9 belongs over here somewhere. And let's see if I can grab that and pull it together. Yeah, negative 3.1 belongs furthest to the left. Now I ought to change these to match what I'd originally had. That's 8. That's 15 halves. And this is negative square root of 10. Okay, the third thing to know from chapter 2.1, for chapter 1.1, is these properties of addition and multiplication. You've learned all of these back in Algebra 1. You've probably learned most or maybe all of them even before then, too. You do need to know all these properties, so read your textbook and make sure that you do. But in this video, I'm only going to have time to focus on these two, the commutative property and the distributive property. Let's start first with the commutative property of addition. You've known this commutative property of addition since you were a little kid, though when you were little you may not have called it that. You certainly knew how it worked. You knew back when you first started handling money that 3/4 plus 1/4 made $1, but likewise you knew that 1/4 and another 3/4 made $1. It didn't matter which order you received these in. We make use of that in situations like this. If I had to add all of these together, I'd rather put the like terms next to each other before I do the adding. So let's actually call out those like terms by changing the color here. All right, all the x's now are easy to see, and I want to put them all by each other. So I'm literally going to drag them around with these plus signs in between. And now it's easy to see similarly that the y's belong together. Let's put both those at once. And now it's a whole lot easier to combine these. Now if you're particularly picky like me, and God help you if you are, but if you are, you might find it easier to put the negatives later and the positives earlier. So I can just keep moving things around thanks to this commutative property of addition. And now I can combine those, and separately I can combine those to get my answer. Looking at the commutative property of multiplication, similarly, here's a problem that's easier to solve if I can move things around. I can figure out what the negative a half times negative 3 is, but it's a whole lot easier to think of what negative a half times negative 2 is, because it works out much more easily. Negative a half times negative 2 is positive 1. Now I really only have 1 times negative 3. There are going to be lots of examples this year where moving numbers around, as long as they're all being multiplied, is allowed. And that's an important point that I've got to stress. Let me go back here. The only reason I was allowed to move these numbers around in this addition problem was because all of them were addition. There were no subtraction operations going on, no multiplication, no division, no mixing of operations. It was all addition. The commutative property only applies when you're only adding, or in this case, when you're only multiplying. Next, the distributive property. Now, you probably remember this from Algebra 1. You learned that you can distribute the term that's outside the parens to all of the terms that are inside the parens. So this 3 gets distributed to both of these. And what you end up with is 3 times 2x is 6x, and 3 times y is 3y. What I want you to also keep in mind, though, is this. Let's say you started out with the 6x plus 3y. And let's say you were told that was equal to 18. You can go backwards, too. You can change that 6x plus 3y by factoring out. Really what you're doing is using the distributive property in reverse. You're factoring out 3 from both of these. And now this becomes a whole lot easier to solve. Instead of dealing with this, I've got this, which I can divide by 3. As long as I'm dividing both sides by 3. Now those cancel out, and I'm left with 2x plus y is equal to 6. A simpler result. And the reason I was able to do that, once again, was because this distributive property can be run forwards, but it can also be run backwards. And often we will want to do that this year. I'm not going to have enough time in this video to get to the fourth of the things I want you to learn, so I'm actually going to unfortunately have to make 2 videos. So I'm going to stop here and save this video, and then I'm going to make you another one about unit analysis.